Here is the answer for the day one bell work. Question A, write Gay-Lussac's gas law. It's P1 divided by T1 equals P2 divided by T2. Question B, the pressure of a gas in a container is 45 kilopascals, so that's pressure number one, at 200 degrees Kelvin, that's temperature number one, and that temperature is already in Kelvin. What is the pressure, so P2, in the container if the temperature is increased to 300 Kelvin? That will be T2. So when reading this word problem and underlining the measurements, I see that it has to do with P1, T1, P2, T2. So I'm going to use Gay-Lussac's law instead of any of the other gas laws. So start by writing the formula. P1 over T1 equals P2 over T2. And then make the substitutions. For P1, 45. For T1, 200. P2 is our unknown variable, and T2 is 300. Now solve the equation. This equation can be solved by multiplying by 300 on both sides, because multiplying by 300 would cancel out where it says divide by 300, leaving the variable P2 alone. Or because this has the format of a proportion, you could solve using the cross multiplication technique. 200 times P2 is equal to, and then on the other diagonal, 45 times 300. Then to get P2 alone, we're going to divide by the 200 on both sides. The answer is P2 equals 67.5. This is a pressure, and the other pressure is measured in kilopascals, so this label is kilopascals. Now question C. The pressure of a gas in a container is 1,000 millimeters of mercury, so that's pressure number one. At this temperature, 60 degrees Celsius. This isn't directly the T1, but it can be used to get the T1. You have to change to Kelvin, so 60 plus 273. That makes 333 Kelvin. What is the pressure? So that's asking for P2 in the container if the temperature is decreased to 30 degrees Celsius. This other temperature will help us to get T2. 30 plus 273. So the value of T2 is 303 Kelvin. We have a question involving P1, T1, P2, and T2, so it's Gay-Lussac's law. P1 divided by T1 equals P2 divided by T2. And then make the substitutions. For P1 is 1,000. For T1 is 333 Kelvin. P2 is our unknown variable, and T2 is 303 Kelvin. This equation can be solved by multiplying by 303 on both sides, or by doing the cross multiplication technique. 333 times the P2 is one of the diagonals, and then that's equal to 1,000 times the 303. That's the other diagonal. Then to get P2 alone, divide by the 333. The answer for P2 is 909.9. And the label for this pressure is millimeters of mercury.